Right, I'm just going to talk about water containers. Before I get started about water containers, right? Water containers, I mean, if at all you take nowadays, anywhere you're seeing the buzzword or Docker container or Kubernetes, right? So but the base for Kubernetes is knowing how to create the respective Docker and Docker images. Okay, so first of all, water containers, right? So if at all you take the virtual machine, so there will be one physical machine where you will be having a hypervisor, and on top of that you will be creating multiple virtual machines, something like you will be creating Linux instance, Windows instance, or something else, right? You will be creating them. So but if suppose in the guest OS, right, you, if at all you wanted to host the Python application or Flask application, right, you would be installing the respective dependencies for that to actually get started. Something like if it is a Python application, it might use some requirements like Flask, some other things which are required for the Flask, the particular Python application to run. So we will be installing all of them, and then you will be running the application. So when you are going to VM2, right? So again, if at all you wanted to create the or run the respective application, you need to run all of them. I mean, basically, you need to create the binaries, and also then only you would be able to run the respective application. App one, app two. Similarly, right? This one. So now if suppose if at all there is some upgrade that has happened, so you wanted to go from 2 point Python 2 to Python 3 or Python 3.5 to 3.7. So if you upgrade in one, right, it will not get automatically upgraded in the other virtual machines. That is how the virtual machines are bound to each other. So in order to overcome the situation, right, we are having something called as containers. You will be having underlying hypervisor, then operating system, and then there will be a container engine. In our case, that we are going to use Docker. And on top of that, you will be creating a container image, and you will be using, and you can host this image anywhere. And whenever you are using this image, right, everything, all its dependencies also comes with itself. So you can just go and you can launch this particular Docker image anywhere. You can run it anywhere. So that is what the advantage with it. So now, right, since we have packaged all of its dependencies all together along with the application code, you need not go ahead and it is not like you need to install again the dependencies like how you install it in a VM. Since everything is packaged, just go and run the respective Docker container, and you would be getting all its dependencies, and you would be able to run the application. Okay, so that is what the advantage it is. And the containers are very lightweight. So if at all you take the virtual machine, right, they will be very much heavyweight. So when you're actually going to in the real time scenarios, right, when the being lightweight, right, it will be very easy for it to scalability, right, comes into picture, and it will be very easy to for it to scale up. So and also just to serve the application, and once it scales up, since it is a container, it will just immediately start the container, and immediately, right, you can get the application running. So that is, those are the advantages, right, of using the containers with respect. So if at all you see the advantages, right, as I told, it is portable, it's a very lightweight, it's a very lightweight, right, it is very small in size. And dockers, right, are isolated from each other. So not one, each Docker container is treated as one complete entity. It does not communicate with another containers until you specify you specify it to communicate. And producibility and scalability, right? So this is where, being very small in size, you can just simply go and get the respective application scaled up immediately. So that is what is about containers, right? So in order for us to learn about containers, we need Docker. So guys, don't worry about if you are not aware of these concepts, right? I will walk you through completely about all of this one when we are going to discuss about GKE, that is Google Kubernetes Engine. So for now, just I wanted to give it short demo. Okay, so as I'm telling, right, so what a container, so I need first a Docker on my machine. So I'm just going to give Docker, and if at all I give Docker PS, right, it will be giving if Docker is running or not. But all you see, right? I mean, since mine is a Mac, I can see the Docker desktop is running on my machine. So that is the reason I'm able to run this Docker PS command. So Docker PS, what does Docker PS does is it will be giving you what all Docker containers that are running on the particular machine. Okay, so there might be some containers that were run or that got stopped. So if you give docker ps hyphen a, you will be getting all the containers that got even stopped. Okay, since we are not having anything, right, we are just leaving as. Okay, so for when it comes to creating docker, right, container or something, the first and foremost is we need to create docker file. So what is a docker file, right? It's nothing but it will consist of few Linux commands in order to build a respective image. So I have got a Docker file. So I'm just going to give cat Docker file, right? If at all, cat Docker file. So basically, it is just having simple Linux commands. Okay, if at all, I'll explain what is from Python 3.8 Slim. So this is nothing but you're actually downloading the base OS for this particular application to run. So this OS will get downloaded, and after that, right, you are setting up what is the actual working directory. So basically, there will be a directory created in that particular the container image, and with this particular slash app, and you are going to copy all of its contents, right, whatever it contains, docker file, everything, right, in this particular folder to slash app folder directory. And then you are running pip install flask comma boto 3. Basically what are these doing is they are actually installing these dependencies. Flask is a dependency, boto 3 is a dependency, and you are exposing this particular application on port 80. And you're just simply saying that run this particular command whenever this particular image container gets started, cmd. So basically what are cmd entry point, we will be seeing it in detail. So this is the docker file, right? So in order to create the image out of docker file, what you have to do is there's a command called as docker build, then what hyphen t, that means you are tagging this. Hyphen t means tag what name you wanted to give to your docker image. So I'm just going to give it as class cap. Okay, and where my docker file exists. So this is the docker file. It is case sensitive, guys. It should have a capital D and file, and here in this particular folder it exists. I'm just giving it, and I'm giving enter. So now it will make use of the docker file, and it will create my docker image. Okay, so if at all you see, all of these are layers. Okay, so just that you can ignore that. So just if at all you give docker images, right, it will build the docker image. So now it has built our docker image, which is called as flask cap. That's what we have given here, right? We have tagged it as flask cap. So now that docker image is created. So actually in this particular, right, I'm also having one app.py. So if at all I give cat app.py, this is nothing but a simple flask application, which will, I can just don't demo this one, don't worry on this one, right? Basically you can think of this as a simple Python application which actually connect, which actually takes input form. I mean, what's the username, password, and what's the username, first name, last name, and email id. So that's what, anyway, I'll demo that now. So basically, since we have created Docker image already, right? So once the Docker image is created, we will run this Docker image and form a container. Okay. So what we will do is for the command for that is Docker run. Okay. Then hyphen D, it will run in dash mode. Okay. And hyphen P. That means on what port. Okay. What does this hyphen P means? Okay. Hyphen p means on what the container port binding it to the local system. That means your container port, basically, right, your the inside the application, inside the container, we actually exposed the we actually gave a command called as expose 80. That means your flask application will be listening on port 80. So that port 80, I am binding it to my local host 80. That means if at all, once I run this container, if at all I give curl localhost, I should be able to get the respective image of the application. So anyway, I'll be showing it. And then what is the image that you wanted to use? I'm just going to give flask cap. Right? This is the image. So then what is the image that you created? I'm just giving it. Okay. So if at all you run this command, so there will be a container that got created. Now you can just give simply docker ps, and if at all you see here, there is a container that is running, and this is a Python app, and this is actually listening on port 80. That means the container port I am binding it to my local system port, okay, on 80. So now if at all I give curl localhost, right, I should be able to get the uh, whatever application that is running in the container. Okay, I can just simply I can just simply run an incognito window, and if at all I give localhost here, I should be getting the I should be getting the this is the web page, right? That is actually this is nothing but this particular application is coming it from the container that we are actually hosted. Okay, so I can input some data. Okay, I can input some data. But actually, I'm just storing this in a particular database, and just I can, if at all I give submit, right, it will go on save in the database. Okay, so now this is about the container. Okay, so okay, now if at all I stop this, right, so in order to stop this Docker, right, if at all you go to Docker PS, okay, now you can just simply Docker stop, and this will get stopped. Okay, so now if at all now you see that if at all I give docker ps, it doesn't give anything because docker ps only will give you the running containers. So in order, if at all you want to identify the containers that also got stopped, right, you can just simply give docker ps hyphen a, and that will give you all the containers that even got stopped. So now, in order to stop this completely, you can just simply give docker rm and then the container ID. This will remove completely. So even if at all now you give docker ps hyphen a, it does not exist. Okay. Now you can now docker images, right? If at all I give and you want to remove this docker image, delete this docker image, you can just simply go and give docker rmi. That means remove image, and you can just simply give flash cap. Okay, that deleted the particular docker image as well. Okay, now there is no docker image. Okay, now again, if at all you wanted to create the respective docker image, just you need to have the docker file. Just go docker build, then you give what is the respective file you wanted. This time I'm just going to give python app. Okay, this is the name of the this will be the name of my image that I'm creating. So now it's just getting created, and it got created. If at all I give docker images, I'm getting the python app. So I can just simply run like what we have seen previously, right? docker 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 run hyphen d then detached mode hyphen p. I'm going to expose 80 to 80 port, and then I'm just going to give python app. Okay, now unable to find, oh sorry, there's a typo. Just a second, guys. So there's a typo and it got completely screwed up. Why it's not stopping? I'm just terminating this, guys. So Python app. So now the container got created. Docker PS. I can just simply go, and if at all I hit it on my machine localhost 80 port, right, I am getting this images. So this is a simple app, right? I can just simply go, yeah. If at all I submit, okay. So XYZ, okay. It is just going and submitting the detail. It is just feeding the details to the my DynamoDB. But I'll just this is the image I have created for one of the AWS project. So I can just change this to Cloud SQL. So if at all you see, it's getting to that one. So basically, right, this is about the short demo of about containers, right? So now that we are having containers, right? So I mean, so once the container is created, so we need to host this on Kubernetes environment. Okay, so on AWS we are having GK, which is called sorry on GCP we are having GK, which is a Google Kubernetes Engine. So how to get that implemented there, right? We will just see. So I'm just stopping this one. Docker. Okay, all right. So now everything is done. I removed everything. Okay, I removed everything. So on the GCP console, right? If at all you go to the GCP console, okay. So if at all you go to the GCP console, right? In the left hand in the left hand, the left hand side, right? These three lines. Just come here. There is something called as Kubernetes engine. So overview. Okay, basic in order to actually create or host the respective applications on Kubernetes engine, what you need to do is you need to have something called as manifest files. Okay, so we are going to create manifest files for whatever application that I showed. So there is something called as deployment files. Does any one of you have idea about Kubernetes already? Does any one of you have an idea about Kubernetes?
No, sir.
All right. Okay. No, no worries. Don't worry about that. We'll get started. So, in order to create any manifest files, right? There is something called as deployment pod. I'll explain that services and everything. So, but at the moment, just think that okay, at the moment, right? Whatever containers that we are creating, in order to run them on Kubernetes, you would need the respective Kubernetes objects. So deployment is one of the Kubernetes object. So this is a manifest file. So we will create this manifest file. So in the GCP, so basically we will create first a cluster. So Kubernetes cluster will create. Okay, so okay, basically there are two modes called as autopilot mode. That means Google manages entire thing of your respective fleet management. There is another mode called as manual where we have to take care of that. So I'm just going to give a normally, and once you create, I mean, basically, right, there is a GUI that goes ahead and creates all of this one. Once the cluster is created, right, there will be a cluster that got created, and then you can deploy your respective containers uh, onto the respective Google Kubernetes engine. So there is in the content, right? I'm covering GKE. I'm covering GKE, right? Okay. Yeah, I'm covering GKE. So where I'll be discussing about all of these concepts there. Okay.